Bismillahirrahmanirrahim. Welcome to the new video lecture of the Oxmetrics. In first video lecture, I already discussed about the general overview of the Oxmetrics and how to import the data in Oxmetrics and use of this calculator in order to convert log form and take lake and all other functions. And one thing is necessary to keep in your mind that in order to open the Excel file in Oxmetrics, it is necessary to keep your data in Excel 97 2003 workbook format. So in this video lecture, I will show you further functions using one question. Let me open the question. You want to examine the relationship between money supply and interest rate. Yes, start with 4 lakes of each variable in Oxmetrics. And in part A they are asking you for the regression, estimate the following regression and write the results. So first of all, we need this equation, this model in our Oxmetrics. So how to bring this LNMS means log of money supply, and there is the 4 lake terms of money supply as well. Log of IR, ln means natural log of IR, and 4 lake term of the IR as well, and epsilon t is the error term. So basically this is the ARDL model. Why it is ARDL? Autoregressive distributed lake model. Autoregressive means the dependent is itself regressing, as well as there is the lake term of the independent term. So this is ARDL model. Let's solve first part A, then we will move to the other parts as well. I already imported data and converted it into the log form, so you already know how to convert this into the log form as well. So first of all, go to the model, and this is time series data model for time series, and all modules single equation dynamic modeling using PCB formulated. Is first of all we need none and LMS and log and its constant term. Then take the 4 lake of money supply as well. Yes, basically this is equivalent to this equation. So we need to, you can deselect one of these one, to get unselected we need to double click here, so it will disappear. So only 3 lakes, but we required one more lake as well, so I put lake in lake 4 of IR. Click OK. Yes, this is the your regression result. So the LMS1 in first lake of log of LMS coefficient value is this one, and all these standard error t values and probability values. So in this case, if you see here, if there is the double steric over here, double steric means variable is significant at one level, means if there is one steric means that 5% the variable is significant, 5%. So if you see in this case, normality test value is 0.28. 0.28 means it is greater than 0.05, so we do not reject H0. So if we do not reject H0 means there is a no problem of normality, means our value, our regression is normal. If you see heteroscedasticity, there is no problem of hetero because the probability value is 0.29, this one 0.4291. It is greater than 0.005, so we do not reject H0. When we do not reject H0, it means there is no problem of hetero as well. So reset test, reset basically it is the Ramsey reset test. Full name is, I will show you what is Ramsey reset test. This is your Ramsey reset. Ramsey reset means a regression equation specification error test. Ramsey reset test. Ramsey reset. So this is used to check a specification bias, and it's null and alternate set in this way. H0 there is no specification bias. H1 there is the specification bias. There is a specification bias in null hypothesis, and there is no specification bias in alternate. So we need to reject H0. If we do not reject H0, means there is a problem of specification bias. So you know how when the specification bias arises, either you include the irrelevant variable or exclude the relevant variable, or due to any measurement error, specification bias may arise. In our case, if you see, the result is 0.2657. It is greater than 0.05. So we do not reject H0. When we do not reject H0, it means when we do not reject H0 means there is the specification bias. So we should reject H0 in order to free the result from specification bias. Move further. So this is all about the regression of the result. In next part, they are asking you to apply lake structure analysis to check the significance of different lakes, whether all lakes are significant at 5% significance level. If not, then re-estimate the model by using the accurate lake length. So we need to apply the lake structure analysis. In order to get lake structure analysis, go to the test and dynamic analysis. Okay, then there is the lake structure analysis second part. Click over here and okay. Yes, so this is our result. This table is relevant for us. Test on the significance of each lake. So if you see a lake 1 value, probability value is 0.005. So we rejection means significant. It is lake 2 is insignificant, lake 3 is insignificant, and lake 4 is again insignificant. Only lake 1 is significant because its probability value is less than 0.05. At 5% only lake 1 is significant. Yes, if not, then re-estimate the model by using the accurate lake length. So the accurate lake length is only lake 1. We need to remove other 3 lakes from our model and re-estimate it. So go to the model and formulate it. Keep only lake 1 from LMS as well as from IR as well. So this is our accurate model and re-estimate it. So this is our re-estimation result. And apply the restrictions on all lakes of the money supply and interest rate and indicate the validity of joint exclusion restrictions you have applied, whether your model is dynamic or static in nature. So basically you need to apply another test, which is joint exclusion restriction test on money supply and interest rate. So go to the test and there is the another exclusion restriction. Yes, okay, we need to apply restrictions on both lakes. With the help of control you can select both. Okay, now if you see the value is less than 0.05 probability, so we reject H0. When we reject H0 means the restrictions are invalid. It means our model is dynamic in nature, not static. So our model is dynamic in this way.